Welcome to the Explainer. I'm your host. Think of me as your personal exam strategist. Today, we're stepping into the ring with Cambridge IGCSE Additional Mathematics. Think of this exam like a boxing match. You gotta float like a concept and sting with a perfect calculation. Whether you're working through syllabus codes 0606, 0580, 4024, 4037, or 4040, the winning strategy is absolutely the same. We're going to dive straight into review exercise 2 and transform it into a clear, thematic roadmap to exam mastery. This isn't just about crunching numbers. It's about understanding the underlying mathematical architecture that examiners are actively testing. By structuring our approach today, we're going to completely demystify these advanced concepts and turn what looks like an intimidating past paper into a highly predictable pattern. Let's get into it.
To make sense of these diverse problems, we've organized our explainer into 5 distinct mastery zones. We'll jab our way through the algebra and inequalities, cross into sketching mathematical curves, and then hook our way into conquering polynomials. From there, we'll decode cracking logarithmic equations and finally ground the whole shebang in real-world exponentials.
All right, let's step into Zone 1, the algebra and inequalities. This is the foundational footwork you need for the entire Cambridge exam.
Take a look at this absolute value challenge from question 1. It's a classic test of whether you know how to navigate dual solutions. You see those vertical bars? The absolute value of 5 minus 2x equals 12. Now, they might look straightforward, but they are a total trap for the unwary student. You have to recognize that the expression inside the bars could evaluate to either positive 12 or negative 12.
So, the crucial takeaway here is that there isn't just one answer, but 2 precise coordinate values that satisfy the equation. By splitting the absolute value into its 2 potential realities, one where 5 minus 2x equals 12 and one where it equals negative 12, we land perfectly at x equals negative 7 over 2 or x equals 17 over 2. Missing one of these simply means leaving easy marks on the table. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along, let's pivot to Zone 2, sketching mathematical curves. Let's see how visual analysis builds up your spatial reasoning.
Question 9 asks us to sketch these 2 related logarithmic curves, identifying their asymptotes and figuring out exactly where they intersect the coordinate axes. Sketching a natural log function like y equals the natural log of x minus 1 requires you to instantly recognize the inherent shape of a logarithmic curve. But more importantly, you need to see how that minus 1 shifts the entire curve horizontally across your grid.
Now, what's really fascinating here is that comparing the 2 curves reveals they behave as reflections. They are bound by the exact same asymptote but are moving in completely opposite directions. The vertical asymptote for both is the line x equals 1. That creates a hard boundary that neither curve can ever cross. So while one curve heads off towards positive infinity on the x-axis, the other mirrors it, heading towards negative infinity. It's a beautiful demonstration of how a simple sign change in the domain completely flips the graphical behavior.
With those curves mapped out, we escalate to Zone 3, conquering polynomials.
Let's look at question 4. It throws a massive degree 4 polynomial right at us, but gives us a single lifeline, the factor x minus 2. We're asked to break it down completely. A degree 4 polynomial can look incredibly intimidating on an exam paper, right? But being handed that first linear factor is literally like being given the master key to unlock the entire equation.
We can trace the logical flow required to solve this through 3 distinct steps. First, you set up your long division or synthetic division using that known factor of x minus 2. Once you divide that out, boom, you are left with a cubic equation. Then, you systematically break that cubic equation down further and further until you are left entirely with linear factors. It's a pure test of your stamina and algebraic precision.
And this brilliantly illustrates the clean set of 4 linear factors that you must extract to secure full marks. We end up with x multiplied by x minus 1, multiplied by x plus 2, multiplied by our original key x minus 2. Seeing a complex degree 4 polynomial collapse into these 4 simple linear expressions is honestly one of the most satisfying moments in algebra. Okay, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries.
Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's catch our breath and dive into Zone 4, cracking the infamous and complex simultaneous logarithmic equations. Here we have a simultaneous puzzle involving multiple log bases, and it demands absolute precision and a rock-solid grasp of your logarithm laws. In the first equation, we have base 2, where the addition of logs dictates that we multiply the inner terms. In the second, we're working with base 5. A huge mistake students make is just smashing these together. You absolutely cannot do that. You have to expertly convert them from logarithmic form into exponential form to isolate your x and y. The answer key reveals two perfect coordinate pairs, proving that methodical substitution leads straight to a dual solution. By converting the first equation to x times y equals 2 to the power of 6, and the second to x minus y equals 5 to the power of 1, you create a very standard simultaneous equation system. Solving that yields x equals 4, y equals 2, or x equals 9, y equals 3.
Finally, we've made it to Zone 5. We're taking all this abstract math and grounding it in tangible, real-world exponentials.
Math review can sometimes feel, well, incredibly abstract, but question 8 anchors us with a very real scenario, calculating the depreciating value of a vehicle over time. Here, V represents our dollar value, T is time in years, and we are using the natural exponential constant E with a negative rate to model exactly how a car bleeds value the second you drive it off the dealership lot.
We know the initial value from the formula, but the real test is algebraically solving for the exact time it takes to lose a third of its worth. We need to find when the car hits $8,000, which is 2/3 of 12,000. By setting the equation to 8,000 and dividing both sides by 12,000, we get the fraction 2/3 equals e to the power of negative 0.2t. From there, we just deploy our natural logarithms to isolate t.
The final calculation reveals it takes just over 2 years, 2.0273 years to be exact, for that brand new car to drop to 2/3 of its original value. Now listen closely. This level of precision is absolutely key in the Cambridge exam. You must show the exact decimal representation derived from dividing the natural log of 2/3 by negative 0.2. Don't round too early.
This application shows exactly why mastering exponentials matters well beyond the exam paper, guys. It's literally the language of real-world finance and physics. Whether you are calculating the decay of a radioactive isotope or the financial depreciation of a company's assets, the mathematical mechanics at play here are completely identical.
To wrap up our explainer today, let's look at question 11. This is a rapid-fire test of your foundational logarithm consolidation rules. After all the complex modeling and simultaneous equations, the exam often loops right back to test your raw technical fluency. Can you instantly apply the product and quotient rules of logarithms to a purely algebraic expression? Let's find out.
By adding the logs of a and b, we multiply them to get ab. Subtracting the log of c means we naturally divide by c. The result is this incredibly elegant expression, log base 5 of ab over c. As you continue your exam prep, ask yourself, are you just memorizing steps, or are you truly seeing the logical connections that make these mathematical structures so powerful? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer strategies. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.